So here in this case, if we have marked the nodes, we have assumed the direction of the current for each branch. Now apply the KCL at node A, find out its equation, then apply the KCL at node B and prepare its equation. Now I will start with the first point. Applying KCL at node A, we will apply the KCL, that is Kirchhoff's current law, at node A and we will prepare its equation. I will write the first point. Applying KCL at node A. Begin. We will apply the KCL at node A. If we are applying the KCL at node A, how is the KCL at this point? Incoming currents is equal to outgoing currents. I1 is incoming, I2 is outgoing, I3 is outgoing. This equation will be I1 is equal to I2 plus I3 is the equation. Is it right? If we have this equation, then try to calculate value of I1, I2, I3, simplify it and name this equation as equation number 1. How is the calculation of I1? This is the complete branch. We have to think about the complete branch. What is the potential here? 0. Negative to positive plus 30 minus VA divided by 6 means, in short, this is 30 minus VA divided by 6, which is equal to, are you getting me? 0, negative to positive plus 30, 0 plus 30 is 30, minus VA divided by resistance of this branch, which is the 6, is equal to I2. I2 is the current in this particular branch. How is its value? Or what is its value? This is VA minus 0 divided by 3. Its value will be VA divided by 3 is the I2 plus its third current, which is I3, that is current in this branch. How is the current in this branch? VA minus VB divided by its resistance, that is 10. This VA minus VB divided by its resistance, which is the 10. Now simplify this equation and name this equation as equation number 1. If we are simplifying this equation, this is 30 upon 6 minus, it is VA upon 6, which is equal to VA upon 3 plus, it is VA upon 10 minus, it is VB upon 10. This is the value. Now I will shift this VA to this next side and we will take the VA as a common. In that case, VA is 1 upon 6 plus it is 1 upon 3 plus it is 1 upon 10. Then minus it is VB upon 10, which is equal to this value is as it is, which is 30 divided by 6. 30 divided by 6. Now, how much is the value of this bracket and this division? Anyone? Please raise your hand. I will unmute you and we will complete this equation and we will name this equation as equation number 1. Yes. Yes. Ruchira.
Yes, sir. 0.6 VA.
0.6 VA.
Minus 0.1 VB.
0.1 VB.
Equal to 5.
Is equal to 5. This is the equation number 1. Is it right? Yeah. Now, Saurabh. Correct your value?
Yes, sir. Correct.
Okay, fine. Now here, if we have the equation number 1, in the similar way, we will apply the KCL at the node B and we will find out its value. Is it right? Now, what we will do? We will apply the KCL, that is Kirchhoff's current law, at the node B and we will prepare second equation. Now, I will write the same. Here, applying KCL at node B, we get. We will apply the KCL at node B and we will find out its value. If we are applying the KCL at node B, how is the KCL? Look at this node. This is incoming, and this is outgoing. This I3 is incoming, I5 is incoming, and the I4 is outgoing. Is it right? Now, how to find out these values? It is a point of concern now. I will discuss here. If anybody has any doubt, please raise your hand. I will answer your query. This I3. How is the I3? VA minus VB divided by 10. Which it is VA minus VB divided by 10 is the I3. Plus I5. No need to use the potential difference formula for the calculation of this I5 because its value is already known, which is 1 ampere. That's why I will put 1 only, which is equal to I4. I4 is the current in this branch. Is it right? In this branch. And what is that value? It is VB minus 0 divided by 5. That is VB divided by 4 is that value. Is it right? Means whenever we have the current source, the nodal analysis method becomes more simple. Is it right? Means we have to take this value of the current as it is, which is I5 is this 1 ampere. That's why I have taken 1 ampere. Now simplify this equation. It is VA divided by 10 minus it is VB divided by 10 plus 1, which is equal to VB divided by 4. I will shift this VB on this side and this constant on the next side. In that case, it is VA divided by 10 minus VB is a common, then it is 1 upon 10 plus it is 1 upon 4, because whenever we are shifting this value on this side, that is become minus VB upon 4, and that minus VB already we have taken it as common, it will remain plus 1 by 4, which is equal to minus 1. Now find out this value of this whole bracket. I guess this value is the 0.1 VA minus. How much is the value of the next bracket? Yes, anyone? Yeah. This way. Rishikesh.
Sir, 0.35 VB.
0.35 VB, absolutely fine. 0.35 VB, which is equal to minus 1, and this is the equation number 2. Fine. Now we have the two equations and the two unknowns. Now solve the two equations. Is it right? Solve the two equations and find out the potentials VA and VB. Now this is the equation number 1 we have with us. This is the equation number 2 we have with us. Now solve these two equations using your calculator and mention or tell me the value of potential VA and value of the potential VB. Just I am waiting for your answers. Use your calculator, enter these values in the calculator and try to find out the values of the potentials VA and VB. Yes. Yeah. I will select someone who has not answered previously. Ruchira.
Sir, VA is 9.25.
9.25 volt and VB is
5.5.
5.5 volt. Yeah. Madhuri.
Yes, sir. Correct.
Rishikesh, is it right answer?
Yes, sir, correct.
Okay, fine. Now, if we know the VA and VB, and now we will try to find out the currents. We will find out the current I1. We will find out the current I2. We will find out the current I3. We will find out the current I4. We will find out the current I5. Generally, in the examination, only one value will be asked. But here, we are trying to find out all the possible values. I1. What is the formula for I1? Already we have taken here. 30 minus VA divided by 6. It is 30 minus VA divided by 6, which is equal to 30 minus 9.25 divided by 6. Calculate its value. I will take the answers at the end. I2 is VA upon 3. VA upon 3. VA is 9.25. This is 9.25 divided by 3 to find out its value. I3 is VA minus VB divided by 10. It is VA minus VB divided by 10, which is 9.25 minus 5.5 divided by 10, this value. Then I4 is VB upon 4. This is VB upon 4, which is equal to VB is already known, which is 5.5. This is 5.5 divided by 4, find out its value. And finally, I5 is already known, which is 1 ampere. That's why no need to calculate the value of I5. Otherwise, you will calculate, you will get the same value. This is right. Now, I am expecting the answers from your side. How much is the I1? Yeah. Saurabh.
45.
Sorry? Point?
3.45.
3.45. Yes. Next. Madhuri. Ruchira.
Oh, I2 is 3.08.
3.08 amperes. Anyone again? Yeah. Rishikesh.
Sir, I3 is 0.375.
0.37 amperes.
I4 is 0.375.
0.375. I3.
1.375.
1.37 amperes is I4. Now anyone who is having the answers, I will check the answers and then we will proceed further. Yeah.
Yes, sir. Correct.
Yeah, fine. Now here I will conclude this particular problem.